Namaste. In the previous videos, we have discussed about the calculation of inductance for isolated conductors as well as two-wire conductors. Okay, and while deriving the inductance, we have assumed that those conductors are solid in nature, that is, single stranded conductors. But in reality, you won't come across such type of conductors. Most of the conductors are stranded conductors. Okay, so in this learning dialogue video, we are going to discuss about these stranded conductors. Okay, so different types of conductors, that is stranded conductors in particular. Okay, so why we are going for these stranded conductors? Okay, the main reason for going for stranded conductors are one is the flexibility. Okay, so to have more flexibility for the conductors, and the other one is will have more tensile strength for the conductors when you have conductors with multi-strands. Okay, so in case of multi-strand conductors, you are going to have layers of conductors starting from a single conductor. The top of that you will have strands like that. You will have multiple layers of these conductors one over the other. Okay, and while construction, these strands are going to be twisted in the opposite direction so that they will not unveil from one another. Okay, so to have the compact nature of the conductors will uh, wind in the opposite directions. Okay, so that is how these conductors are made, and the conductors are standard to provide flexibility for the stringing. So if you want to calculate the total number of strands in the concentrically stranded cables with total annual space filled with strands of uniform diameter, you can also calculate by using this simple equation, that is n equals to 3x square minus 3x plus 1, okay, where x is the number of layers. So what are the central strand that is there at the core of the conductor, that we also will consider as a starting layer, first layer, that is first layer. Okay, and if you want to calculate the overall diameter of the standard conductor, you can also use this simple equation: d is equals to 2x minus 1 times d. This d is the diameter of the strands, and x is the number of layers. Okay, so if you look at the example for this standard conductors, you can see how they are constructed in this pictorial diagram. So you will have this multiple layers in the strands. Okay, just if you start with this central one, this is the first layer, this is the second layer, third layer, fourth layer. Okay, so this particular conductor has 4 layers. Okay, and these each layer, the strands in each layer are twisted in the opposite direction. For example, if you consider this second layer, if their strands are twisted in forward direction and the right hand side, then the strands in the third layer will be twisted in the opposite direction. Okay, so in the left hand side, again the fourth layer is going to be twisted in the right hand side, so that they will be compact. Okay, so this is how these standard conductors are made normally. Now when it comes to the material that is used to construct these conductors, normally we use aluminum conductors. Okay, so for internal purpose, that means residential purpose or industrial purpose, we use copper wires, but these outdoor, since these are in outdoor conductors, we prefer aluminum for two reasons. One is uh, less costly compared to the copper, as well as they are light compared to the copper. At the same time, these are the two advantages with aluminum conductors: light and less cost. Okay, weight wise they are light, and also cost wise they are less compared to the copper. But there are disadvantages also. Okay, compared to the copper. Copper is will have more conductivity and more tensile strength also. More tensile strength also. Okay, so these two are the disadvantages, but these disadvantages can be overcome uh, in different ways. For example, if you consider this aluminum conductor, obviously since the conductivity is less, more we need to use a larger cross-sectional area of the conductor. Okay, and So there is one advantage with the increase in size of the conductor also. Okay, when you go for high voltage transmission lines, especially, then we will experience a special phenomena called corona. Okay, so that is because of the stresses that are present on the surface of the conductor, voltage stress that is present on the surface of the conductor. So as the size of the conductor increases, what happens is the stress on the surface of the conductor will reduce. That will further reduce the corona effect. Okay, so that is the advantage. What are the advantages that you have considered compared to the copper that now become the advantage also. Okay, so that is how this uh, conductivity was addressed. And next, coming to the tensile strength. Okay, another disadvantage of these aluminum conductors is tensile strength. To address this tensile strength, what we will do is we are going to keep steel strands at the center core, okay, which will have a higher tensile strength to uh, keep these aluminum conductors. Okay, so we are going to put some steel strands at the center. Okay, so you can see in this picture that here we have some seven steel strands in the first and second layers, and the remaining third and fourth layers we have 24 aluminum strands. Okay, so the main objective of keeping these steel strands is to increase the tensile strength. Okay, so this particular configuration is called aluminum conductor steel reinforced conductors. Okay, and this is the most commonly used configuration for overhead transmission lines. Okay, even when you go for EHV lines, you will find this type of standard conductors with aluminum conductors on the outside and steel reinforced at the center to increase the tensile strength. Okay, so these particular conductors are called standard conductors. And if you go for extra high voltage lines, then what we will do is sometimes we will also keep some paper in between the conductors to increase the size of the conductor and reduce the corona effect. Okay, and if you go for further higher voltage, then the conductors are separated with spaces to reduce the corona effect. Okay, what is this corona and how to reduce this corona and what are the reasons for corona? Those details we are going to discuss later in the next videos. Okay, in this video we are discussing about the different types of conductors, and these are the such type of conductors where we use spaces to increase the size of the conductor. Such type of conductors are called bundle conductors. Okay, just if you can also see such type of conductors when you go to your just on the town side. You can also come across some if you come across any 765 kV transmission lines, then you can see our 400 kV transmission lines. You can also see such type of bundle conductors. Okay, so the same normally in transmission lines. If you look at the transmission towers, you will find either three conductors or six conductors if it is a double conductor. Okay, and if you come across any 400 kV line or 765 line, then in case of 400 kV line, you can also see each phase consists of four such conductors. Okay, so a group of conductors. Okay, so those conductors are called bundle conductors. And if it is 200 kV line, then you will have two conductors in each phase. In that way, if you look at the transmission line tower, what happens is for each conductor, if it is 400 kV line, you will have four standard conductors in each phase. So if it is double circuit, obviously 4 into 3, that will make one circuit, that is 12 conductors you can see. On the other side you will have 12 more conductors on the second circuit, so you will see something around 24 conductors. Okay, so normally people will have a misconception that how the conductors are placed side by side. Okay, but those conductors are of same phase. They belong to same phase. They are not of different phases. So there won't be any problem. Okay, and those conductors are called bundle conductors. Okay, so these are the different types of conductors that are used for the transmission lines. Okay, and in the next coming videos, what we are going to do is we are going to we'll try to calculate the inductance because of the currents that are passing through these conductors Since till now we have considered only single conductor, now you have a group of conductors. How the inductance is going to be can be calculated if you have a group of conductors in your transmission lines. Okay, okay. That we are going to discuss in the coming video. Thank you.